Welcome to part 2 of Module 201C. We're going to look further into the principles of AC circuits. Before we were talking about reactance and resistance and how that creates a total impedance on our circuit, which limits our total current. However, there are more things at play that also affect the total resistance of our circuit. Most of the time, these items only come into play when we talk about things like transmission lines, but it's still good to know what these different things are. Some of these terms you'll recognize from first year, and some of these terms will be brand new concepts to you this year. First, let's talk a little bit about the difference between AC and DC resistance. If you were to take a coil and put an ohm meter on it, you'd get a ohm value back. That ohm value is based on the physical resistance, therefore just the resistance and not the impedance or anything else of that coil. That's also referred to as the DC ohmic value. However, when we have an AC circuit, not only do we have to think about the DC ohmic value, we also have to think about the reactance of the circuit. So inductive reactance and capacitive reactance. And we also have to think about four other types of losses being eddy currents, hysteresis, dielectric losses, and skin effect. And all of these five components together create what's called an AC or an effective resistance. The first thing we're going to talk about are eddy currents. Eddy currents are any time that we get a circulating current inside a solid metal object. This can happen inside a core for a transformer, or a core for a motor, or even inside a conductor itself. Inside our AC circuits, we have a constantly changing magnetic field as our current rises and falls. As that magnetic field also changes, if it is around a solid core, it will induce a voltage within that core, and the resulting induced voltage will create a current flow. If the core is solid, that current flow turns into a short circuit, which creates a lot of heat. Anytime that we create a heat inside our circuit, it takes energy and power to do that, and that is considered to be a loss. It will end up reducing our efficiency and possibly ruining some of our components. Another property that exists inside AC circuit is called hysteresis. Hysteresis can also be referred to as molecular friction. As my magnetic field changes, the directionality of my electrons also change, and as my electrons go from one side to the other side and back again, they end up rubbing up against other molecules. That rubbing on other molecules will create heat, as it will any type of friction, and that heat is also considered to be a loss. Both eddy currents and hysteresis are what we call iron core losses. And they are called iron core losses because we typically see them inside the iron core of a transformer or a motor. There are ways that we can reduce the amount of loss that we have in these different systems. With iron core losses such as eddy currents, if we laminate our core, so to put multiple different metal pieces together and make sure they're all electrically separated, we also make sure that we reduce any possible current that can be building up inside those. If we limit the amount of space current has to travel, we limit the heat that's also created. However, the laminations put together still create the same magnetic effect, so we're not affecting the magnetic properties of the circuit, we're only affecting the amount of current that can be built up inside our eddies. When it comes to hysteresis, we need to find a way to reduce the friction. And one property of silicone is that it is a great way to do exactly that. The result is that most cores are made of what is called silicone steel, which is steel doped with a silicone compound, in order to reduce that molecular friction, therefore reducing the heat that's created by hysteresis. Beyond iron core losses, we also have losses that will affect a single conductor. One of those losses is called the dielectric loss. The dielectric effect is whenever I pass a high voltage through a conductor, it will actually pull electrons out of their orbit inside the insulator. Of course, pulling those electrons out of their orbit takes energy. That energy will also create heat, and that heat is considered to be a loss. So anytime I pass high voltage through a conductor, it will deform or distort the electron paths inside the insulator, which is an energy loss for us as well. Another type of loss that we see on AC conductors is called skin effect. Skin effect is directly related to induction. Even on a single conductor, I can have induction happening within that conductor, which means I can see a counter EMF and therefore counter current flow happening within that conductor itself. What typically happens is that that counter EMF builds up in the very center of the conductor, therefore limiting any current flow inside that center. This forces all the electrons that we're actually using to do our work to the outer skin on the wire. If you ever look at a transmission line from a power company, you will see that the center is actually a steel core. And that steel core is there for tensile strength, so to make sure that the conductor doesn't break over time. But it works well because of the skin effect. The skin effect is moving all the electrons to the outside edges away from that steel core. Therefore, we don't have to worry about the higher resistance of the steel, and we're still transmitting in the copper section of the wire. Now we can have an idea of all the different things that can affect our AC circuits. Not only do we have to think about our resistive losses, such as just the resistance of the wire itself, as well as any impedance or capacitance losses that we can have inside this, but we also have to think about things about eddy currents and hysteresis and how much heat is being created by those two iron core losses. Or do we have a dielectric effect, which is the distortion of the electrical field inside the insulator? Or do we have any concerns with the skin effect based on how much counter EMF is being created inside the system? Some of these things will be affected by voltage. Some of these things will be affected by frequency. All of these things need to be considered when we consider the total effect of AC on a circuit. We're now at the end of Module 201C. You should be able to describe the three different current limiting properties of an AC circuit being resistance, inductance, and capacitance, and how they affect the total impedance of the circuit with your inductive reactance and capacitive reactance. You should also have an understanding of other things that can affect the total resistance of a circuit, being our iron core losses, our skin effect, and our dielectric losses. If you are unsure of any of these principles inside this module, please make sure you contact me or reread through the module again. In the meantime, you can return to Blackboard, complete the knowledge check, and then go on to do exam S1-2.